Mabuhay! Magandang umaga po sa inyong lahat. That means good morning. I'll speak Tagalog. So I'm nervous, so I wrote down some things. So I just want to say the facilities here are fantastic. And when we came yesterday, I was so impressed. Mga Filipino, you all look so great. Dapat sana po ay dinala ko ang aking barong Tagalog. So I didn't bring my formal wear like you all did. So some of you might be wondering about my familiarity with the Filipino language. I've been asked a lot about that. So I actually lived in the National Capital Region from 1996 to 1998. That's a story for another time. But I came back to the Philippines in 2007 as a young PhD student. And I had just completed my master's thesis on the LEDRINAE, and which I'll be talking about today. But I was very eager to come back, but in a research capacity, which was new for me. It took a lot of effort to set up that first visit. It was not easy to contact the research group here to find them and to create a working relationship with the new colleagues here. But it finally worked out, and I'm so glad that it did. And I feel proud, actually, that I played a small part in helping to connect working groups I'm in the US with the Filipinos here. And for me, that's borne a lot of fruit. But I know that it's had some ramifications positively for many researchers. On that visit, I actually came here to UPLB, if you can believe it, back in 2007. And let's just make sure I say everything I want to say here. I was able to join the research group of Dr. LEDRINAE, Dr. Jun Lit, and I actually thought he retired. He still works here, so I'm going to go see him. He's at the museum. And he politely invited me to join his research group, his students, and we went to Planthoppers Island, which was a great expedition. That was a lot of fun. And Mom Shang was there, and many students, and I'm still in touch with many of these until today, many of these people. And these have become wonderful friends and colleagues, and I've actually been fortunate to return to the Philippines several times since, always in a research capacity. So in order to get to the substance of my presentation, I will forego with further sentimental storytelling, but I'll just say, nagpapasalamat po ako sa mga Pilipino sa kabaitan at pagtulong sa akin. So that just means I'm thankful to the Philippines for everything that they've done for me in my career. So I need to insert here briefly some information on my employment. So I'm an entomologist for the USDA. And I work for APHIS PPQ in New Orleans, handling quarantine issues. And I run a diagnostics lab that services commodity import, export, and domestic survey programs. So that all of that's absolutely relevant to what we do. But I'm supposed to mention that I'm not actually here representing the USDA. So I'm here on my own dime. I actually run a virtual research lab that I started before the pandemic. And so when the pandemic started and everything went virtual, we already knew how to do that, so that was cool. So I have been training undergrads, and we're slowly publishing papers on various topics. Taxonomy of Neuroptera, actually, and soon what you see here. So I think that's everything. Okay. So let's get into the LEDRINAE. Don't press that button. So, I'm going to be talking about new genera and species of LEDRINAE and other information. So what I mean by that is I'm actually going to give a review of the subfamily, which many of you here know something about LEDRINAE. Maybe I can add some information to what you know. And I'm going to review the results of work that I did back in the day, which is old as new again. And I'm going to be talking about outgroups and where do the LEDRINAE fit, and what is a LEDRINE and what is not a LEDRINE. So the LEDRINEs are a medium-sized subfamily of leafhoppers. As currently defined, they have approximately 300 species and about 40 genera and 5 tribes. They have a worldwide distribution but the various tribes are more or less geographically constrained. They're pretty much geographically constrained. They're by and large associated with woody trees and shrubs. There's one tribe that has been described as being primarily associated with grasses, but I have some data to suggest that they actually are also on woody shrubs. So here are some examples of LEDRINEs, and many of you will be familiar with these. These are popularly photographed. You'll find them online on imaging fora. So they're fun. They're bigger than other leafhoppers in general. Comparable. Some of them are quite large, comparable to like large Proconians. As regards to their ecology, they're presumably univoltine in the northern hemisphere. There may be some multivoltinity in the tropics. Their life cycle is typical of leafhoppers, so they oviposition into the leaf epidermis, and the eggs enclose on the plant host, and then the larvae go through various instars, and so they have these wing buds. But the adults, of course, are winged and sexually mature, almost always. Almost always. They're sexually mature, but they're not always winged, or fully winged. And then they're arboreal, and some appear to be gramineous or gramineous. And an attribute that seems to correlate with this group is varying degrees of camouflage, sometimes profound. And this is associated with pigmophyly, which is adherence to surfaces. So they're going to be found on leaves and bark, and they're going to mimic these surfaces. And also, I remember we were in Taiwan and we saw some that mimic nodes of twigs. Very good mimics. You almost couldn't see them unless you knew to look. So again, just to remind you, you can look and see leaf mimics, node mimics, bark mimics. Okay. So more on their ecology, just to be relevant to our conference here. Are they potential vectors of disease? Well, Nielsen in his work in the 60s noted that some Xerophilea in particular are pests of grasses, at least they've been described as such. He asked the question, are any of these vectors of pathogenic viruses? And that's an open question, many decades old. I don't know if that's been answered. As has been discussed, there are symbioses that occur in these leafhoppers, in this case fungal, so I'm going to talk about a paper later. But really, plant host information is lacking for most of the LEDRINEs. They're not well understood. So the potential for transmission to agricultural commodities isn't clear. It's possible. So it's something we have to watch out for, like in my job. I screen pests that are collected on commodities. If we ever got a non-native Xerophilea, for example, they would be quarantinable or actionable. So there's 6 species that are endemic to the US, but there are several that are not. The same applies for pretty much any LEDRINE. If we ever got a LEDRINE intercepted on a commodity, it would be actionable because we don't know whether it's a vector or not. So by default, we would probably fumigate the ship. Okay, so here's the higher level classification of the LEDRINE, and let's dig into this a little bit. So this information comes from the extensive systematic review that I published with my advisor. It was my first big paper. I'm very proud of it because I was a young student when it was published, and it's long, it's like 125 pages. And it's not a perfect work with the 2020 vision of age, you know, looking back on the paper. There's so many things I would have done differently. I'm going to try to do a little bit of that in this talk, kind of reorganize some information so it's easier to assimilate. For example, we made a small error in spelling, and Dimitri kindly pointed out, and with Stu's help. And so Dimitri kindly worked with me, and we published a correction of the name so we could get the nomenclature correct. So here are the tribes again. We have the Xerophiliinae. There are 6 genera in the New World, the Western Hemisphere. In the Afrorubriaceae, there are 5 genera, although several of these are new, and I'll be talking about them today, and they're all in South Africa so far. There's a single genus of Rubriaceae in Australia. There's this cool single species in Chile that I elevated to tribal level, Auchenorrhyncha. And then the LEDRINAE is the large group, and it's all old world, 30 plus genera. So here's the distribution. A lot of these graphics are extracted from the 2009 publication. So you can see the LEDRA, that's the large, I've got LEDRA Orida there, a picture. And it's distributed across Africa, one in Europe, all of Asia, and into Southeast Asia and Australia. And then the other tribes are, we've got down in the bottom right, the Rubriaini are in Australia, and then the Afro-Rubriaini down in South Africa, and then Auchenorrhyncha over in Chile. And those are all small groups. And then we have the vexing Xerophlyaini throughout the Americas. Okay, so when I fell into this project as a young master's student, I actually wanted to work. I told Chris when I first met him, because he sponsored, he and my advisor sought out a Peak grant, and they brought me in. I was very fortunate to have that opportunity to learn taxonomy. And the question that we had on this group was, what are LEDRINEs? Is any part of the LEDRINE as they were constituted monophyletic? And as with so many old groups that haven't been revised in a long time, they become a bit of a collection bin, a junk drawer. So there were taxa that maybe didn't belong. The definition for the LEDRINE was maybe a little bit loose, and so it wasn't clear if there was a true LEDRINE, what that was. And then we were also curious, what is the sister group? What's this core group of LEDRINE related to? How do they fit into the psychedelity tree? So with that in mind, I gathered together as many representatives of the genera of LEDRINE as that was represented at the time, and I did a cladistic analysis. I didn't have any molecular data. We'll get to that later. So on the left is the phylogeny generated from the full taxon set with all of the potential outgroups. I included a lot of things that were like LEDRINEs that could possibly be outgroups of LEDRINE, and then also many things that were described as LEDRINEs, but those are all put in the analysis. And then once I got kind of a well-supported, more or less well-supported result, then I pruned off all the things that didn't seem to belong. And that's what's on the right there. And so we figured out, I looked at 235 morphological characters for 75 taxa. So that's a pretty good sized morphological data set. Took a while, okay? Lou was very kind, my advisor. He says, you should get a PhD for this. I'm like, I'm open to it, but they just gave me a master's degree and I moved on. Okay, which was fine. So we figured out that the star marks what I thought was a cohesive group with synapomorphies, okay, for a LEDRINE. Well, that within the group, we had lineages that seemed to have synapomorphies themselves that were cohesive, and that were also geographically defined, which was a nice secondary result that makes sense evolutionarily. So this basal group, or I shouldn't call it basal, this group that's occupying this position here is the Xerophlyaini, and then we have the Afro-Rubriaini. They came out as sister to one another, and collectively they were sisters to another clade, and the stem group there is Rubriaini, and then we have this monobasic taxon Auchenorrhyncha, and then the remaining LEDRINE. So that is the constitution, the phylogenetic constitution of the 5 tribes. And the Auchenorrhyncha and the Afro-Rubriaini were new tribes that I erected. So that meant that all these other things were not LEDRINEs, okay? So this includes some things that were called LEDRINEs, and then also many of the outgroups that we included that we knew were not LEDRINEs. And so that gave us clues about maybe where things belonged, but there was some confusion, so that continues until now. So here's some of the things that were in the outgroup material, and you're going to know some of these. Eulipines have been talked about, Aphrodines, Iacines. Don't know why they didn't come out as a single group in my analysis, but we'll get to that. And then what I ended up calling Tartosine, which I can see Dimitri rolling his eyes, but that's okay, we'll get to that. Okay, and then I did not include any Celidiine or Hylasine. I didn't know to put those in there. maybe the hyoscines, but I hadn't really considered the solidines at the time. All right, so here's some of those outgroups. Okay, we've got the Stenoledra, and you'll notice that these things kind of look LEDRINE-like. Flathead, dorsal ocelli, sometimes punctate, tegmina, or surfaces, rugose characteristics, kind of textures, and so, and some of them are quite large, okay? And I've included underneath their current positions as I understand them. Now, this one in the top middle was not in my analysis, but I put it here because I want to point some things out about it later. And then we have the tartacine, okay? So these all fell out in the outgroup material. And you may notice the Clinonana in the top left, that was in a talk yesterday. I saw it in the iocine phylogeny that was generated, and I said, yep, I figured that out, not a LEDRINE. It's right in the middle of the iocines, which is cool. So, that's a nice segue into kind of a point I want to make in this talk, which is, now that so much time has passed since I published, because we published in 2009, I did this work almost 20 years ago, and so I want to know how well have my results weathered time, you know? Have the results that we published back then been supported in more recent analyses? How well did we do? So this paper came out by Nishino et al. In 2016, and they looked at fungal symbionts of leafhoppers, and they actually highlighted LEDRINAE. And here's their tree, and they point out that they actually sampled 3 LEDRINEs. They were doing some Sanger sequencing of 18S and 28S. So they included 3 LEDRINEs, which were Ledropsis, Ledra, and Tituria, and you can see they concluded that they were formed in monophyletic clade. Well, how does that compare to the work I did based on morphology? Well, here are the genera, Ledropsis, Ledra, Tituria, and they're all in the LEDRINAE. So that's kind of a nice result, but very small taxon sampling, but very gratifying. So has this sort of, result been universal? Well, unfortunately not. So let's look at Chris's paper. And Chris already pointed out some of the drawbacks of this paper. So this paper is really strong in many ways, but has some drawbacks. He's talking about short branches for clades within the psychedelity and so forth. But that's where the LEDRINEs come out. So there may be a signal here that the LEDRINAE are actually paraphyletic. So what we see is that the xerophyllae are falling out in this one clade, whereas the petalocephala that was included in the analysis is in a very different spot. So that's disconcerting, It's like, maybe they don't actually go together, right? So, but when we look at other psychedelics in the analysis, including the outgroups that I had looked at in my analysis, we see that they're coming out in different places. Now, it's gratifying to see that the iocines they sampled all came out together, but that wasn't true for some of the other groups they looked at. The tartacines weren't together. And then Chris mentioned the recent paper by Hu et al. That I believe you were a co-author on that as well, Chris. Yeah. So, kind of a similar result. Many more taxa, but kind of a similar result. So we have xerophyllae coming out in one spot, and the LEDRINAE coming out in another. Now this is a nice analysis because instead of just a single exemplar from tribe LEDRINAE, they have 4 genera, and they also finally had a sample of Hespenidra from Chile. And to my delight, they came out together. So at least LEDRINAE plus Hespenidrinae, which are quite far apart geographically, seem to be monophyletic, at least according to this analysis. So that's gratifying. But that xerophyllae is not with them. What does that mean? So, not sure, but it's kind of hard to know what the data here mean because, again, it's not just the LEDRINAE that maybe are falling out as a polyphyly. We have that happening with the Aphrodite. Iocine are nice and cohesive. Tartacines are split. And then these other groups, Pseudodyne and Hyoscine, are kind of tucked in there. So what conclusions can we draw from this? Well, the xerophyllae appear to belong with the iocines, maybe. Maybe also some part of Tartacine, maybe Aphrodite, maybe Auchenorrhyncha, maybe even some other subfamilies. LEDRINAE plus Hespenidrinae may belong in a superclade with another part of the Aphrodites, another part of the Tartacines. Possibly. Maybe some hyalocines, maybe some C-lydiines. Right, so this is an open question, and this is going to segue into the end of my talk, okay? The positions of the remaining ledrine tribes, Rubriani and Afro-Rubriani, are unclear, but my estimation, this is my speculation, is that likely they're going to belong to one clade or the other. So back to these guys, let's go through this quickly because I'm going to run myself out of time here. This one caught my attention. I did not look at this. This is a genus of Nearctic Japanines in the IACPH. Just keep that in mind as I go through this little demo. So when we look at the in-group and the out-group, if we're trying to figure out what is the putative out-group to LEDRINAE, we would look for something that shares characteristics with the LEDRINAE and has support from morphology and molecular data, hopefully. So within the ledrines, we would probably want to look at taxa that fall out that have fewer changes relative to the stem in terms of evolutionary changes. So we could look at the Hesponidra, we could look at the Rubrians, or we could look possibly at the Aphrodines, Aphrodines, or the Xeropleines. It turns out that the Xeropleinae have the fewest number of steps to the base of the tree, and so with that in mind, and considering some of the data we've already seen, there does seem to be a proximal relationship between some iocines. Well, okay, are we really getting closer to the answer with this speculation? I don't know, but I noticed something, caught my eye that I'd never seen before. When you flip this iocine over and look at its face, it has a very distinctive frontal clipeus and lori. The features and sort of the dimensions are rather similar to Xeroplea. And when I saw it, I was like, wait a second, there are not many leafhoppers that have that face. That's very distinctive. I would like to go back and look at this. You can see there's even similarity in the CD and the punctations and just sort of, so there's some differences in sort of where the eye is and so forth, so it needs to be looked at, but that caught my attention, so who knows? Okay, so one thing that I didn't have in my paper was a really nice graphic showing kind of where the species or the genera fell out relative to the phylogeny. So this is only in this PowerPoint, but here you go. There's the Xeroplea, Plans, Afro-Rubrians, Rubriani, Hesponidrine, and then all of the ledrines. Now, this tribe LEDRINAE does have two major lineages. So it has a stem lineage that's not circled of several Asian taxa, and then it has this petalocephaline clade, and then it has a ledrine clade. All right. So there's not enough time to go through these, so I'm just going to click and just have to remember it all, and there will be a pop quiz at the end. Okay, so these are the diagnostic features for LEDRINAE, okay? So we've got head feature with the crown. These are all things that came out of the analysis that I did, okay? Base features. If you have questions, we can talk about this later. Features in lateral view relative to the notum, boring venation. This is a feature that's very important, but is not unique to the ledrines, the metathoracic CD formula. The row 2 CD and the cucullae associated with them on the hind tibia. And then I can't even remember all these acronyms, so I apologize. But here are the 5 tribes and sort of their diagnostic features. And so I'm just going to click through these. I apologize, but I want to get to the end. So this is from my paper. This is just a sampling of all the LEDRINAE tribe members that I looked at, and again a review of the whole group. So to wrap up here, I want to introduce you to 4 genera, or 4 taxa, I should say, and maybe genera, that I came across in my analysis that I included. They're part of the phylogeny, but they don't have names. So I'm hopefully going to publish these. First is this fun ledrine from Borneo. It's kind of flat, it's big. This is where it goes in the phylogeny. It's within the middle of the ledrines. And again, for the sake of time, I won't go through all these characters. Also, please don't scoop me. Don't put a name on this and publish this. I won't like it very much. I shouldn't have even done this, but I figure I can trust you all. So, Well, I'll just tell you, it's kind of similar to this other genus, Benelidra, which is from Africa, but it has a different aspect ratio. The hind tibia is very different. The size is a little different. The articulation and the hind wing is different. So there's a lot of differences, but also a lot of similarities. And it occurs here in Sarawak area. So there's some people here who have an interest in Borneo. There you go. Sorry that the little stars are in red and hard to see, but that's where this genus is from. So I want to slap a name on this thing, so expect to see that in the future. And then the rest are all Afrorubriines. So we have this one genus. This is where it is in the tree. I called it genus 3 at the time. It's cute, it's tiny, it's from South Africa. Its face is kind of xerofleine-like. And the punctate frontoclypeus and the lack of antennal edges and everything is just very xerophlia-like. And so, but it's not the same. But when I coded it in my original analysis, the similarities pulled the taxa together. Are those real, or is that just kind of a convergence? We need some data, right? Okay, very cool, little black things. Some are green. There's actually several morphotypes in the 4 specimens I have. And here's a cool feature. So when we look at that, as the male, the anal tube is incomplete ventrally. And Chris is the one who noticed this. He pointed it out, so there you go. The Ediagus is that projection off the top of the Ediagus there. I thought those were maybe membranes. That's actually like little hair-like, I don't know what they are, like little sensory hairs or something. They almost look like filaments. Very weird. Okay, genus 4. There it is in the phylogeny. Very different face than, you wouldn't expect that face looking at it dorsally, but it's got this yellow chevron. And strangely, it has this tubercle right in the middle of the frontoclypeus, and that's similar to Zygriota, a xeropleine. That was a character that pulled these tribes together. Is that real? That can't be real. I mean, if you understand phylogeny. So, and you can see the tubercle there in lateral view. Now, I want to point out another thing. All the genera here in the Afrorubriine, they have a strap-like hind wing. They don't have a fully developed hind wing. So that's a thing. Pretty cool, huh? Okay, and I'm out of time, so I'll just wrap up. But here's the last genus. It's pretty cool. It's very similar to Afrorubia. And you can see Afrorubia here in the face. And you can even see the hind wing, the little tiny hind wing underneath the tegumena. So, all right. So that's where they go. These are all the taxa go. I might almost finish on time. So the outstanding questions are, we have an idea that the Hespinidraini do belong with the LEDRINAE proper, but what about the Afrorubriine? We don't know. So Chris, you need to go to South Africa and get some specimens. Maybe you already know the answer to this question. I'd be interested to know. Then there's the fossil that we published. I published with, I was included on the paper, and I was very grateful for that. But June Chen thought this was a paracarcinine. I don't know if I liked that answer, but we went with it. And I kind of think these look like the little Afrorubriines we talked about, actually. They have a lot more in common with them. So Chris suggested to me a while back, a couple years ago, that I should redo my analysis and tuck the fossils into there. And then lastly, Dimitri, my friend, was kindly needling me about what I did with the Stenocatini and Embryini. And I do have to say that's probably the weakest decision, in my opinion, the taxon placement we made when we published. I don't think that's well supported. We did that because of the position of the phylogeny, but in the end, the focus was on the in-group and not so much on the out-group, and so this needs to be reconsidered, revisited probably. That's what I got. Thank you very much.